creating a camera. All right, here in this section, we're now going to be creating a camera, having it draw the grid, or draw like what it sees on the grid. So the first thing we're going to want to do is, probably like create the camera. We're also going to want just a query for the grid to get something within a range. So if I give it a coordinates between like, x, y, and x, y, I'm going to want to then say, okay, give me everything in there. So probably like a start and end. Because from this point, so like 0, 0, all the way over to here. Tell me what that is. Is that, because then we're just going to say, hey, give me everything in those cells. Let's figure out what that would look like. So in our grid, we have all these cells, which is our vector hash map. So we're going to want to figure out which one of these cells to get out. And then return a vector of references to these objects. That's what I'm thinking. And because I have these cells, yeah, I really want sort of like the top left corner and the top right. Maybe even like just a rectangle. I wonder if, can I just pass like a rect bounds? Essentially, I want a query. So I want a query for, or maybe like a search. I don't think I need to mutate anything in these. I might need to. And then we want like the bounds, like the beginning and the end. And it should be like a rectangle. So maybe like a start X, start Y. And an end. An end X. And an end Y. And we're going to return probably a vector with references to game objects. All right, let's go ahead and get started with this. So let's say I pass in 0, 0. And then all the way to the end of the screen. We want to find every cell that is inside of there and then return that. What would that end up looking like? Do I want to search for just like through every single cell? Or do I want to like figure out the coordinate system and just say, hey, if you're within those bounds, just like go into every cell, grab, get it out and grab it in. So it sounds like the first thing I'm going to want to do create an empty vector. I'm going to push into here. Let's go ahead and create our start X and start Y as grid coordinates, and like end X, end Y as grid coordinates. So this is going to be our start X, and we do this right here. Our game object location X, so this is going to be the start X divided by cell width. And then this is your cell width is a F32. Okay, that's fine. You're an F32, but then we need to create this as a U size. So like that. Okay, so that gives us our start X and our start Y as indexes. We're going to want to do the same thing for the ends. Okay, so now we have our coordinates for the end. Then we're going to want to essentially loop through the entire grid, and as long as the index is within those bounds, how would this work? If I have like all the way down, so as long as we're within that. So for y index in, probably this is going to be index start y. Then I want to go to index end y, but I want to have this be inclusive. Mismatch types. Oh yeah, I'm just not returning this. Okay, so that's just yelling at me about that. In fact, at the end here, let's just go ahead and return game objects, and then you'll be much happier. All right, so what are you upset about? Expected a block. Do you not like the triple dots? You don't like the triple dots. Okay. So this is not inclusive. So I think we're always going to be missing one thing. Am I going to have to like +1 onto this? I can't remember if inclusive, like the inclusive one is in nightly only right now. Okay, so that gives us our y index going down. So then we want to loop through the x index going across. Okay, so then we're going to loop through all of the everything going in, sort of the width-wise, each cell. So then we can get access to the cell, essentially. For those cells, we want to iterate through them, extract them out, and then push those into these game objects. So game objects.push. And this is going to be self.cells, y index, x index, dot, can I just get everything? Oh, I don't think I can just get, wait, can I? No, I don't think I can just get everything. So I'm going to want to loop through. Okay, so let's do a now a loop through. So and I think this is going to be the key, which is going to be the game object ID. And then the value, which is the game object. All right, so it gives me the ID, the game object itself, I don't actually want to extract these out. Let's just iter that. That way we get a reference to it. And then we're gonna take all these game objects and push them into this. It's game objects. Okay, so now we're gonna get a vector of these references and return that. Okay. So if I query and I give it like the locations, I should be able to. So let's do this once at the beginning. So we create our grid. We populate the level. Let's debug, calling grid.query. And let's start with like 0.0, so top left. And let's go one full, maybe like 1.5 over. And that should give us 2 cells all the way down. Or actually, you know what? We know exactly where things are, don't we? We know that the floors start on 400. And then the players are on like 350. So if I do, and that's at the top left of that. So if I don't do 0, 0, let's do 0x, 350 down. And then the end x, let's do like 3 over. So 3 times 50 is 150. And I want 400 now. So let's see what this gives us. Do we only get like a small subset of them? All right, so we should get floor, 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 player, and start. So what is that? 1, 2, 3, 4, 5 things. So you have player, start. So what is that? 1, 2, 3 floors, 1 player, 1 start. So 1 player, 1 start. Floor, 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 floor. 4 floors? Did I include that by accident? I may have miscounted. But it looks like our query is correct. Like we're actually getting just what we want to get out of it. So that's really exciting. So in that case, I should be able to create a camera. We're gonna have to have a location of where the camera is. We're probably gonna want to, well, we know we're gonna sync this to the player. So like have it based upon the player's location. How is the player set up for this? Well, the player is just basically based upon the game object. So we have its location as a vector too. So let's go ahead and make it the same thing. Okay, so it has a location of F32s, and then we're gonna have a width and a height. And I don't know if I really care about anything else that it has right now. So we're gonna create our camera. We can create the camera at like location 0, 0. So it's, you know, at the very, very beginning of the level and like contains everything. But we're gonna have to pass in what the width and the height is because it doesn't know what the size of the arena is. Although I might want to do the location just to tie it to the player right away. So let's go ahead, we'll just bring in everything. Okay, so that allows us to create our camera. Let's go ahead and create that and store it in the library. We have our context here, so we can figure out what our world height is. Now we also have that from the game data, so we can grab this off of there too. And then our width, let's to begin with only set our width to be maybe like 200.0. And we can do like the full height of it. And this can be the camera height. Okay, we're gonna store the camera away. Okay, so that's the first step. Then we're gonna want to have the camera, so when we draw, have the camera use the grid to draw out. So what is this gonna look like? So for self, we're gonna need the grid. Okay, so we're gonna need the grid. I don't know if we need anything else. We have our location. We have everything else. We're probably not gonna return anything. Let's sort of see what happens. We're gonna query the grid with our location. And then our start X and our start Y. So that's actually going to be just our location.x. Our end X and our end Y is going to be location.x plus the width. I'm missing self on these. Okay, self that width, and then, okay, so our end Y is going to be self.height. Okay, so that gives us all these game objects. We're going to loop through the game objects and then draw them. Okay, so they're going to need the meshes and the context. So we need that too. Which of course I need to bring in. Okay, so you're happy there. Now, of course, we have a result that must be used. And I believe this is a custom result. So if I question mark you, then you're just going to be saying, hey, you don't return a custom error. Okay, so that's what it is. Chantilly, hello, good morning. All right, so let's go ahead and return here result. We don't really care about the when things are good. When things are bad, though, we want this to be a custom error. Custom error there. And then when we're all done with this, we'll return okay like that. All right, so this isn't complaining for us. Let's go ahead and now have the camera draw and we'll pass in these things. So in the main library, in draw here. So instead of having the grid do this draw for us, we now want to do exactly the same thing that we have here, except instead of self.grid.draw, this is now going to be self.camera.draw. We need to pass in the grid, the meshes, and the context. So let's go ahead and reorder this a little bit. Self.grid, self.meshes, actually, then just the context. Now you need to be a reference to the grid and a reference to the meshes. All right. And then no errors, only 4 warnings. Let's go ahead and see if we're only drawing 2 things. Oh no, thread panicked at index out of bounds, the length is 10, but the index is 10. Okay, so this is grid RS line 69. So here in query, we went, so we don't want to do this. That's what we don't want to like go a little bit too far into it. There we go. And this is all that we're drawing here. So if I now update the camera and have it move to the right, we should see these things sort of like disappear and then re-add as we sort of pan through the level. Let's go ahead and try that out. So in update, let's go ahead and make our location public here. And then I'll just reach in the main library and update our camera. Now we can sort of see things move as the camera moves. We're only showing like this little bit of whatever the camera can see of the entire level. So that's kind of cool. Now, if we want if we want it to look like the entire camera, like we're following the camera, like we are following the camera, then we're going to want to do that translate first. So what does that look like? I think, let's see, there's a couple choices. We could take all the objects that we have and like move them by the amount that the camera is over to the left. Or we could move the camera and have it be aware of its location and translate itself. How do we do this in the other one? I'm trying to remember. I think we did a translate on the camera's vector itself, and I think that we can do the same thing. I think vectors have that. So in draw, maybe before we do the get the query. Probably not before we get the query, because we need to have it like know where it's grabbing at. It's just more of we want the camera to always like be on the left hand, like fixed to the screen. I think what it is that we want to translate the entire sort of world over, like almost like a graphics translate by the camera's location. That's what it is. I wonder if we have access to that. So is there like there's a transform. Let's get to copy. Applies draw param to rect. Okay, so you must. So there's push. There's okay. So there's a set transform. What we probably want to do is do a push transform, and then a pop transform at the end. And then apply transformations context. Okay, so it looks like a push transform, a pop transform, and then an apply transformations. Okay, so let's do a push transform first, pass it the context, and then the transform itself, which it sounds like we can use as a draw param. Can we just do it straight with a draw transform? Okay, so it looks like a draw param might be better. All right, so draw param here. We want to create a new and then a dot destination. And then we want this to basically convert from the location here. So I think I can do a, we're gonna need a 0.2. Okay, so 0.2 from self.location. I wonder if this will work, or if I have to like multiply it by -1 or something. So if I do that, we're gonna push the transformation. We're going to apply the transformation. Ooh, you're not happy. Oh, okay, so it doesn't like this. Wait, this is an option? Oh, it expected an option and it found this. So I have to actually wrap this in a sum. Oh, okay, so it doesn't like... A drop param can be converted into an appropriate transform matrix by turning it into a drop transform. Param to matrix. So dot dest at the end of here to matrix, like that. I thought I had that. Okay, so you're not happy with that. Oh, do I need to do this? This is off of the dest. Maybe one to the left. Or run to the right, really. Like you. There you go. Okay, so that does the transform. Then we want to apply the transform, I think. And then pop the transform. And you return a game result, which means I need to do, because I'm doing a custom error here, so I need to do our entire match thing. It's actually only the error, so it's really an if-let. If-let error, error. Then in here we're going to return a new, sort of like the custom game error. So like that. Okay, so what are you upset about? Oh, equals. No errors. Let's see if this works. Kind of. So that everything is moving the wrong direction. And not necessarily by the right speed too. That's really interesting. Let's try the opposite direction. Okay. We want apply transfer. Okay, so we want destination from self-location times -1.0. Looks like a magic carpet ride. Yeah, no, it kind of does. Okay, so if we multiply this by -1 to reverse it. Now we have like the camera is moving to the right. So that's really cool. The camera is fully moving to the right. Now, if I make the camera the full size of the level, then everything should look fine. So here in the main library, when we create the camera, so instead of the width 200, game data dot camera width, and run this, and we should now have the camera panning to the right, and we have the full level showing. Now here's one little problem. We're actually grabbing like the cells but not until like they're fully in here. So that's a little problem. We want to probably grab one extra to the right. So maybe we want to have the camera be a little bit bigger on the width. So I'm going to do plus dot cell size. And now everything is very smooth as we sort of move through this level. So this is really cool. And here's our end. It's green. I really wanted it to be red. Let's go ahead and fix that really quickly. In our meshes, create the end mesh. Want you to not be green, but be red. There we go. Now we can change the speed of the camera. We can move that, whatever we end up wanting to do for this. But here we go. We now have our camera. It's panning through the level, and we get to see what we're going to have to deal with as the player to get to this sort of ending spot. So that's nice. I like this. Okay, so we've created our camera. Maybe before we end this video, let's attach the camera. It's not really attaching. Let's fix the camera to the player's location. So that way, when we eventually have the player move around, the camera will just follow the player. So to begin with, we're going to want to set the camera Now we don't know where the camera is, we don't know where the player is because we're creating the player down here. Maybe we need to create the player here. I'm not sure we really do because we know where the player is going to be created. So we can do our width. Okay, so our location. So probably not 0, 0. We want game data dot player dot start x. Now if I do this, and then 0, 0, so the entire height of the world. If I do this, the player's going to be on the left-hand side of the camera. Oh, and we're continuously updating and moving. Let's stop that. That's not the best thing to play with. Let's have the camera offset to the left a little bit. And I think we have something in our game data for this. Camera chase X, that's what it is. So we're gonna start you with location.x. So game data, player start X minus. There we go. And now we just sort of start here in this position. All right, this is perfect. We've now got we've got our player, we've got our camera. Our camera's not moving because the player is not moving. So it sounds like that's probably going to be the next thing that we're going to take care of, is having the player move. But that's going to be in the next video. Obviously, if you're watching the stream, that's coming right up. I'm going to go ahead